All right. Welcome everyone for joining. This is the 26th day of online training on SPSS. And myself, Zahid Pishi, I am a faculty member at Department of Commerce, University of Gujarat, and a PhD scholar at Hadi College of Commerce, University of Punjab, Lahore. So far, we have covered a lot of topics. Uh, since in from our previous session, we have started regression cases and we have considered the first three regression cases that we have analyzed here. For example, the simple regression analysis, multiple regression analysis, and simple regression analysis with binary categorical variable but quantitative dependent variable. And the fourth one is simple regression analysis with categorical independent variable but quantitative dummy variable. Today, we are going to start the case number 5. It is the binary logistic regression case. And always remember, whenever the type of your dependent variable change, the model will automatically be changed. So whenever you are going to use the quantitative or continuous dependent variable, your model seems to be simple or multiple regression analysis. But whenever it becomes binary, your dependent variable become binary, it means it is coded with 0 or 1 or some category, then you are going to change the type of the regression analysis. So today we are going to consider the case number 5, 6, and 7 with your dependent variable is basically binary. So let's start from the fifth case where your independent variable is continuous, or you can say quantitative, while your dependent variable is binary. So as I have shared the data set already with both of the participants, so I will start right from the case where we have discussed the case number 5 as a regression analysis. So here it comes, case number 5, where your independent variable is quantitative and your dependent variable is binary. So from the data that I have already shared with both of the participants, you need to open the case 5 data set from here. So let us discuss. Meanwhile, the software is opening. Meanwhile, we can discuss the detail of this data set. We are interested to know, is there any effect of age on status of heart disease? So we are interested to know whether there is a heart disease or whether there is no heart disease. So your DV becomes binary. It does not matter what is your IV. It will require logistic regression or simply binary logistic regression when your dependent variable is coded with 0 and 1. So first of all, this is the step-by-step procedure, and I will guide you throughout the process in order to understand this procedure. So as a step 1, we need to run the binary logistic regression, where we need to consider status of heart disease as a dependent variable and age as an independent variable, because we are interested in knowing the effect of age on status of heart disease. So our null hypothesis is there is no effect of age on status of heart disease. And our alternative hypothesis is there is an effect of age on status of heart disease. So status of heart disease is our dependent variable and age is our independent variable. So we need to establish a predictive model first. The remaining process I will let you know. So the data set is open. Now let's suppose all these things are not calculated first. So you need to clear all these things. So you have two variable here, age and status of heart disease, where you can see status of heart disease is coded with 0 and 1, which is the first requirement that your dependent variable should be binary. So it is coded with 0 and 1. Therefore, we are going to use the binary logistic regression. So as a first step, you need to create a predictive model for your consideration. So what you need to do, first of all, you go to analyze, go to regression, and here you will find binary logistic. This is the regression that we are going to use. You need to simply click on it, and then you need to put your heart disease status as a dependent variable and your age as a covariate variable here. You don't need to do anything from the remaining options. You just need to click on OK, and you will see uh, there are some results like case processing summary, dependent variable encoding. You just need to ignore these aspects, especially you don't need to consider the block zero beginning block. Block zero beginning block, you don't need to consider any table from block zero. You just go straight to block one. This is the area. These are the tables that we are going to use for interpretation purpose. First of all, you can see here omnibus test of model coefficient. So these this table indicates whether your model is statistically fit or not. So here the sig value is less than 0.05. So we can say that our model is statistically fit. The next thing that you need to see here is the model summary table, that is Cox and Snail R square. It is about 25.4%, which indicates that age is explaining 25.4% variation in the dependent variable, which is status of heart disease. Again, the next one is the classification table. Here you need to see this particular value, which is the overall percentage. It indicates the prediction accuracy. So here, the prediction accuracy is 74% for our model, which is very good prediction. Then you need to see the variable in the equation. Here you can see age in years with beta value of 0.111, and you can also see the exponent p, which is 1.117, and the significance value is less than 0.05. So this is highly significant value. So how to interpret this model? First of all, we need to consider the step one here. So this is the procedure that we have adopted. We have gone to regression, binary logistic, then we put our dependent variable in the dependent list and our independent variable into covariates with it, which is age. And after doing this, we have gone to block one method. You need to ignore the block zero results. You need to consider the block one results here, because block zero is the zero prediction model. So we don't need to consider the zero prediction model here. We need to consider the block one here. So you can see here, always consider block one results and ignore block zero. So these are the value which should be less than 0.05. So reject H naught and conclude that there is an impact of age on status of heart disease. So we can conclude here that age is significantly impacting the heart disease here, because this value is less than 0.05. Then you need to see the Cox and Snail R square, which is about 25.4%. So Cox and Snail R square indicates that the variation in the status of heart disease is 24.4%, which is explained by the variation in age. Then you can see the classification table. From the classification table, you need to consider the overall percentage, which is basically indicating that your model is 74% correctly predicting your dependent variable. So prediction of negative instances 78.9, prediction of positive instances 67.4, while the overall percentage of correct prediction is 74%. So this is a good prediction as per the model. So next thing that you need to see here, you need to see the sig value of your independent variable here. Independent variable here is age, and the sig value is less than 0.05. So this value is less than 0.05. So we reject H naught, and there is an effect of age on heart disease status. With 1 year increase in age, there is 1.117 times the exponent b is basically the times. So when you increase 1 unit in the age or 1 year in the age, there is 1.117 times chance of having a heart disease. So this is an equal chance. With an increase in age, you have the probability of 1.117% times chance of having a heart disease. So this is the beta value. You need to consider this coefficient value for your predictive regression model. So how can you create your predictive regression model? You can see here YSHD, that is the probability of having heart disease, is equal to, first of all, you need to put your constant value, which is minus 5.309. You need to put it into your regression model. Then you need to put your beta coefficient value of age. That is 0.111 here. Because this value is positive, so you need to please place here the positive value and then age. This X sign is basically the multiplication sign. So we are going to use this as a predictive model in order to consider the further step. So what we need to do, the second step is the creation of Z distribution for predictive model. So how can we create the Z distribution? First of all, we go to compute variable. Then we consider in the compute variable, we need to put our predictive model as a Z distribution here. We need to consider the same model here, and we can compute it as a Z distribution. And it will show us this column. So let us consider this procedure practically. So this is the value, this is the coefficient value, and this is the simple value. So what we need to do, we go to transform compute variable, and we need to write here Z distribution. You can write here distribution. So what we need to put, we need to place here our model. So if you see here, this is the constant value, minus 5.309. So you can write here minus 5.309. So we have placed the constant value here. Then we need to put the coefficient value of our independent variable. It is positive value, so we need to place here positive sign. And we can write here 0.111. Now, this value is relevant to age. So we can multiply this value with age. So static sign for multiplication, sorry. We need to write here the value again, 0.111, then multiplication, age. So just what you need to do, you need to multiply this value with age. So static sign for multiplication, and then you double click on age from here, like this. Now it looks similar to your predictive model here. If you see here, this is your predictive model. Always remember that in order to consider the further step, you need to create this predictive model, the model like this. Always consider your constant value first. If it is negative, you need to place the negative value here. If it is positive, then you need to consider it positive. Then the next coefficient sign and coefficient value, then multiplication sign and the relevant variable. So this is the predictive model that we need to require for Z-score. So here we have considered it, and we need to click on OK button now. So it is computed You can see here if this command is executed. In order to verify whether this command is executed or not, we can go to our data set. Here, the row is generated, and if you go to the data view, a column has been generated. And if you can see, there are a lot of negative value here. So the second step that you need to consider here is to generate the negative Z. This is the step-by-step procedure. As a first step, you need to run the binary logistic regression that we have run. Then you need to create the Z distribution of your predictive model that we have created. Then you need to create a negative Z. So how can we create it? Let, let me show you the procedure so that we may be able to accurately consider it. After calculating the Z, you need to create the negative Z. So how can you create it? You need to write here negative Z, and you need to place minus sign, and you need to click on Z. This is just a simple procedure. As we have created Z distribution, so go to transform, go to compute, reset here, and you need to write here negative Z. So how can we compute it? You just need to place negative sign from here, and then you double click on Z distribution. Now it will make it a negative Z distribution because it is already negative. So negative multiply negative will make it positive. So click on OK and check whether the command is executed. Yes, the command is executed. You can also verify here. And here you can see negative Z distribution. Now it has become positive Z distribution. So it has changes the sign of your distribution. If it was already positive, now it has become negative. But if it was already negative, it has become positive. So this is the second step that we have considered. After considering the second step, what we need to do, the third step is exponent of negative Z. So how can we consider the exponent of negative Z? So here is the procedure. Creation of exponent of negative Z. So let me show you the procedure first. First of all, you need to write exponent Z. So how can you create exponent Z? You need to write exp within bracket negative Z. So go to here, transform compute variable, reset. Then you need to write here exponent Z. Here you need to write exp within bracket negative Z. Double click negative Z and bracket close. Now this is the particular formula to create the exponent of your Z distribution. So click on OK. So it will execute the command like this. You can verify this is the exponent Z. You can see here the exponent Z has been created and it is also verified here. This is the next step. And after doing this, what we need to do, exponent after exponent Z, you need to plus 1 in the exponent Z. So we go to transform compute variable, reset. Now you can write here 1 exponent Z. All right. So what we need to do, 1 plus sign, and then you need to double click exponent Z from here. So it is 1 plus exponent Z. Click on OK, and it will execute the command. So after doing this, you need to verify 1 plus exponent Z has been created here. You can also verify from the data view, 1 plus exponent Z has been created here. Now, after doing this, the last thing that you can do to generate the probability of having heart disease, which is PhD. probability of having heart disease. How can we generate it? We divide 1 by exponent of negative z. So go to transform, go to compute, reset. Now probability of having heart disease is equal to 1 divided by 1 exponent z. So the last step that you have computed in previously, you need to divide 1 by that last step, and it will generate the probability of having heart disease. So after computing it, if you can see here, now this is the probability of having heart disease. If you manually check if a person has age 20, there is 4% chance of having heart disease. If a person is 23 years old, there is 6% chance of having heart disease. So if a person is, for example, we can see here a largest value, for example, 42, there is 34% chance of having heart disease. So there are a lot of value. For example, you can see here 57. There is 73% chance of having heart disease. So this step will generate the probability of having heart disease. Now, as a final step, what we need to do, we need to create a scatter plot of probability of having heart disease. Now, this is the overall procedure whenever you are going to apply the binary logistic regression. This is the overall procedure. Each time you need to follow this procedure to consider the probability of having something that is your dependent variable. So I need to show you the last one. So creating a scatter plot, after creating the probability of having heart disease, we need to create a scatter plot here. So how you are going to create the scatter plot? You go to graph, then legacy dialog box, then go to scatter and dot plot. And from here, you need to consider simple scatter. And from here, you need to put age in years and probability of having a heart disease in x-axis. You can consider probability of having heart disease in y-axis and age in x-axis instead. So let me show you the procedure. We can consider this as a dependent variable and age as an independent variable. So go to graph, go to legacy dialog box, scatter diagram simple, define our dependent variable is probability of having heart disease and independent variable is age. Click on OK and it will show you a graphical representation like this. Now, this is the graph. On the left side, you can see the probability of having heart disease. And on the right side, you are seeing the age. So here we can see that when the age increases, the probability of having heart disease also increases. So the highest probability is reported on the age near to 70. So any person which is near to 70 is having the highest probability of having heart disease. Now, this is the basically procedure that you need to follow for logistic regression here. So we have created this diagram. Now the next case is the sixth one. That is the case number 6 that we need to consider here. So we can close it like this. And we can consider here the case 6 data for our analysis procedure. The same step-by-step procedure will be applied here, but there are some certain changes that we need to understand here. So I am going to elaborate the overall procedure here. So for example, these are the things that we need to clear here. So there are some data here. First of all, we need to see the specific detail of this data from this example. Case number 6. Independent variable is binary and your dependent variable is also binary. That is the second case. In the previous case, the age was the continuous variable while dependent variable was binary. But in this case, your independent variable is binary and your dependent variable is also binary. So is there any effect of smoking status of mother on the birth weight status of infant ones? So there is no effect of smoking status on the birth weight status of infant burns, and there is an effect of smoking status on the birth weight status of infant burns. So in case 5, our independent variable was continuous variable, whereas in this case, our independent variable is categorical, binary. So first we will have to define our independent variable as a categorical variable in the covariate section of binary logistic regression. So there is a slight change that you need to follow. When you put your dependent variable in the dependent list and your independent variable in the covariate list, you need to define your independent variable as a categorical variable because this time it is categorical, not continuous. If it is continuous, you can consider it as a covariate, but if it is categorical, you need to consider it as a categorical. So here you need to put it and then click on continue. It will show you the similar results like this. And you can see here the remaining things. And you can generate the model in the similar way as we have discussed previously. So let me show you the procedure first here. We go to analyze, we go to regression, then binary logistic, and birth weight. Birth weight status is our dependent variable. Smoking status is our covariate or independent variable. As this is categorical variable, so we need to click on categorical. We need to put it here and click continue and click OK. So it will generate our results. As we have already discussed that we need to ignore the block 0 results. We need to consider the block 1 results. So here it is less than 0.05. So we can say that there is an impact of smoking status on birth weight. Here the Cox and Snail R square is about 2.5%. You can see model accuracy is about 68.8%. And you can see here that the smoking status is negatively impacting the weight loss or weight status of the infants. And you can see here there is 49.5% times chance of having a birth weightage loss in case of smoking status. So we can consider here the detailed interpretation, as we have already discussed that sig value is less than 0.05, therefore H naught is rejected. So smoking status has an impact on birth weight status of the infant. Then R square here, Cox and Snail R square indicates that the variation in the smoking status explain only 2.5% variation in the birth weight of infants. So the overall percentage of the correct prediction of the model is 68.8%. Sig value here is less than 5%. And there is a negative effect of smoking status on birth weight of newborn infants. You can see here the negative value. So with 1 unit increase in smoking status, there is 0.495 time chance of decreasing birth weight of infants. So as we have seen here, there is a negative value of smoking status. So birth weight of infants will decrease if there is smoking status of their mother. So using this part, we have generated a predicted model. First of all, we need to put here the constant value, which is minus 0.383. And then we can place here the independent variable value, which is also minus 0.704. So this is basically the predictive model that we need to create using the same procedure. We go to here, go to transform compute variable z distribution. So we can place here minus 0.383 minus 0.383. Then we need to put the coefficient value of our independent variable, which is also minus. So we can place here minus 0.704, 0.704. And then, according to predictive model, we need to consider our independent variable as a multiplication sign. We can use steric, and then smoking status as a independent variable. So this is our predictive model. So we can click on OK, and it will execute our predicted model. So you can see here, you can verify this is the Z distribution, and these are the values. So as a second step, if you remember, we have generated negative Z. So here we need to create here negative Z. So what we need to do here, put this negative sign and double click Z distribution and click on OK. And it will generate negative Z. So you can verify it. You can see here negative Z is generated. After doing this, the next step, what was the next step? If you remember, the next step was exponent of negative Z. This was the next step. So we go to transform compute variable, reset exponent Z. So what we need to do, ext within bracket, double click negative Z and bracket close and click on OK. After creating exponent of negative Z, we need to create 1 plus exponent of negative Z. So we go to transform compute variable, reset, and then 1, 1 exponent Z. So what we need to do, we need to write here 1, then plus, and then double click exponent Z. Click on OK, and it will execute 1 plus negative Z. You can see here like this. Now, after doing this, the next step was 1 divided by exponent of negative Z. In the previous case, we were interested in knowing the probability of having heart disease. Now we are interested in this case, probability of having weight loss. So here the case is probability of having birth weight loss. So we can have the probability, go to transform compute variable, reset. So probability of having low birth, low weight, low birth weight. So let it be probability of having low birth weight. It means what are the chances that the birth weight of infant will decrease? So it is the probability of having low birth weight. So what we need to do, we need to divide 1 by 1 exponent Z. So click on OK and verify the results. So these are the results. So you can see here, if there is no smoking status, probability of having the birth weight is 41%. And if there is birth smoking status, there is 25% chance of having birth weight loss. So as a final option, we need to see how they have generated. In this case, as we have discussed that our independent variable is also categorical. In this case, we cannot generate the scattered diagram. So when your independent variable is categorical, and your dependent variable is also categorical. It means binary. Both are binary. Independent variable is binary and your dependent variable is binary. In that case, you are going to use the cluster bars. So go to legacy dialog box, then bars, and then you need to consider the cluster bar charts. So you can generate a category axis as a smoking status and cluster by your probability of having birth weight loss. So it will generate like this. So let me show you the procedure. Go to graph, go to legacy dialog box, then bars. Then you need to consider the cluster bars, define. You need to put here in the x-axis what we need to put smoking status. Smoking status as the category axis and cluster by probability of having birth weight loss and click on OK. So it will generate the chart like this. So you can see here, there is high chance of having birth weight loss if that person is non-smoker, and if the person is smoker, then there is low chance of having low birth weight. So these are basically the interpretation of this table, and with this we have completed the case number 6. So, as the time of this session is going to end, we will consider the case number 7, but the case number 7 also follows the same procedure, but there is slightest change. There are a lot of categories of age that we are going to consider. So let consider this procedure tomorrow for case number 7 so that we may be able to analyze the situation more accurately tomorrow. So, do you have any question for today's discussion, Ms. Hina and Ms. Rabia? So please let me know.
No, sir.
All right. So have some practice on this procedure. And the one thing I would like to make you clear is Uh, tomorrow we will complete the regression cases, and after that, we will have one session on explanatory factor analysis, one session on discriminatory analysis, cluster analysis. Then we may have one session on power analysis or sample size estimation. Then we will consider 3 days on process by haste. So it will approximately take 10 days approximately to cover the overall syllabus. So let's meet tomorrow for completing our regression cases. So thank you very much for joining and stay blessed.